Hello, my name is Salvador Escobar, and I'm going to be doing an extraction of DNA from peas. I have already soaked my peas overnight, more than 8 hours, a lot more than that, so they should be ready to go. The first thing I'm going to explain is what is DNA. DNA is the molecule that carries genetic information and for the development and functioning of organisms. Deoxyribonucleic acid. Now the other thing we're going to start with is, I already said I soaked those overnight, so I already poured half a cup here of distilled water, so I got a clean cup here that I'm going to mix with salt. And salt is going to help us to, got 2 packages of salt, and salt is going to help us to break the to help us to precipitate the DNA together, help it clump together when we pour the alcohol in our solution. So again, salt helps to the DNA to stick together. It's called precipitation. When the salty DNA comes in contact with the alcohol, it becomes undissolved. So here we go. We add the salt in here. Just 2 little packages. There we go. So we're going to dissolve this, mix it till all the salt is fully dissolved. So there we go. After these is fully dissolved, and like I said, I already transferred all my peas to the pretzel mortar. So now it's fully dissolved. I'm going to use this teaspoon to transfer some of the salty water about halfway full of my mortar. And yep, you can see everything here. And about right there. And again, this all will help with precipitation. You can move that to the side. You can see peas here with the salty water. We're going to crush them because we decided that the blender method was going to be too loud. So we're just going to crush them here. There we go. Now once this is crushed there, which I think it's pretty good now, some of that right there is going to be our DNA stuff already. So we got this other clean cup, got a cheesecloth here, and we're just going to pour that in this cup. So I don't have a rubber, so we're just going to use this here. We're going to pour it in here. As you can see, that right there should have some DNA already. It does. So we're going to have this in here. Now we'll put this all to the side. Now we got our soap. Now why do we use the soap, the detergent soap? We're going to add half of it, of this container. It helps to the properties of soap to clump the proteins and the lipids. So our DNA is enclosed in 2 sacs in the peas. So this will clump those proteins and lipids and pull it apart, and that's how we're going to get our DNA. So we're going to mix this here, just like that. Now we're going to try not to make too many bubbles. Going to stir that, and like I said, just about half a dropper. So now we already have our 91% isopropyl alcohol that has been in the freezer overnight, so that's pretty cold. Now here we're going to There we go. Gonna pour these into our test tube without making a mess. There we go. That's our soapy DNA juice. So now, once we have this here, it's time to add the meat tenderizer, or the papain, in this case the papain powder. Now how this is going to help, this is going to help, we're just going to add about half of it. This is going to help to break the sac that surrounds the DNA. No, I'm sorry, that's for the detergent. The tenderizer, it's going to cut the proteins, acts like a scissor, and the proteins are in the DNA strand, so it's going to cut the proteins out to leave the DNA by itself. And the tenderizer, like I said, cuts the proteins away from the DNA. So here we go. So we're going to add about half of it. Yep. And we're going to mix it carefully. There we go. You can see that. I'm going to use that unit gently. Try not to break the DNA. Okay, once that's been mixed, we can add the chilled or cold alcohol. And this right here, the purpose of the chill alcohol is going to be, the alcohol is less dense than the soupy or the water, so it's going to be at the top, and that way the DNA is going to move to the top, and when it becomes contact with the DNA will start clumping together. You'll see the DNA forming. So I'm going to add cold alcohol here. And you can see this on top, and you can start, you can already see the DNA forming. And we added quite a bit, but that's okay. You can see that. Let me see if I can get this close. That is DNA at the top. This white clump stuff, it's whitish string-like mucus looking thing is DNA. Let's see if we can get a little bit more to form. Well, oh yeah, it's quite a bit. Now this called precipitating there. Look at all that. Stick together. Now I hope it's not too deep, because I got toothpicks here. The toothpicks are not very long, so we're going to see if we can get it all out. Well, great. We can pour some here. Actually, you know what? I have a better idea. There it goes. You have to improvise here. determined to get this out. All that right here. Oh, you can see a lot more in here actually. Clean all this out. All this here, see that? That's DNA. Quantity wise, we actually got a lot, but unfortunately, well, I've got more toothpicks here. I didn't get the right, my toothpicks are not doing the job to collect all of it, but you can see here, all that is DNA. You can see it all here. Quite a lot. So that's it for this experiment. Thank you for watching. And sometimes you just have to improvise. Thank you so much. And we got quite a lot, but it was kind of hard to collect with the toothpick. So next time I'll probably use a skewer or something like that, wooden skewer, wooden stick or something. It will be easier to collect it. Thank you very much. Thank you for watching, and enjoy the rest of your day.